Tugboats haven't always been so strong, but they have always been essential to the maritime industry. And Foss knows this better than anyone else.
We've been around since 1889, so we're about 117 years old. We were founded by Thea Foss, and she started out by running a single rowboat out on the Tacoma Waterway, and that grew into a thriving launch business, running rowboats. And her and her husband Andrew not only built the rowboats, but expanded into launch services, supporting the sailing fleets. And over the years, they invested into launches and tugs, and it turned into the business it is today as one of the United States' largest tug and barge companies.
Long before the Fosses, steam-powered paddle wheel boats were the strongest tugs. But as the screw propeller gained use in the early 20th century, tugboats became more compact and stronger. But it was the diesel engine that made the tugboat the powerful workhorse that it is today.
The advent of the diesel engine, really the mass-produced diesel engine, really changed towboating. It extended the range. It was a lighter weight propulsion unit that allowed the tugs to not take up as much space in the engine rooms, allowed them to have what we would call legs or more distance capabilities.
But in the 1990s, mega container ships and tankers demanded a new breed of powerful tugboats. In 1993, Foss Maritime built the strongest enhanced tractor tugs in the world, the Garth Foss and Lindsay Foss. These two tugs are stronger, bigger, and faster than their Long Beach counterparts.
These boats are about 150 foot in length. They're over 40 foot in beam, and they run 8,000 horsepower. These boats can exert a direct bollard pull in excess of 170,000 pounds and an indirect bollard pull well in excess of 500,000 pounds. These are really mission-specific designed to stop a tanker at speed.
Bollard pull is the maritime measurement of force that a tugboat exerts when pulling against a stationary object. The more bollard pull, the stronger the tug, and these tugs pull hard.
We're going to just pull straight back now. We had about 65 tons on the line here. See if we can get any more on pulling direct.
What makes these two tugs so strong are their engines. And even more important, their Voith-Schneider cycloidal propulsion systems.
These are the throttle controls to the engines, and these are the controls for the Voith propulsion system.
The propulsion that's underneath the vessel here where we're sitting, the Voith-Schneider propulsion, the blades that hang down here that do all the work. It's a lot different than a propeller. It drives it a lot different.
This unique propulsion system is similar to a helicopter, with its blades extending vertically into the water from the bottom of the ship's hull. Rotating around a vertical axis, an array of 5 blades with shapes similar to airplane wings provide the lift or thrust for these powerful tugs. Mechanically linked, each of the blades smoothly changes pitch to optimize its angle of attack relative to the flow of the water it meets. On command, this smooth and coordinated movement instantly creates the required amount of thrust in any direction required by the tug. Not only is the Voith system incredibly strong, it also provides outstanding maneuverability.
Where we have it heads and shoulders above the conventional tugs, they're not as maneuverable. We can't control their propellers as well as we can. And then plus the fact that we have the 8,000 horsepower, high maneuverability and high horsepower is pretty much the ultimate in ship assist.
As strong as these tugs are, Foss has plans to incorporate even more strength.
With a vessel that has a 20, 25, even 30 or 40-year service life, you have to be looking way beyond what your present market needs are. You have to be looking at your customers and what your industry is doing and building for the future as well as the present.